Voyager, after 45 years in space, sends warning signals to Earth. The Voyager missions are a monumental chapter in the history of space exploration. Launched in 1977, the twin Voyager spacecraft, Voyager 1 and Voyager 2, have been traveling through space for over 4 decades. Designed initially to study the outer planets of our solar system, these two spacecraft have gone far beyond their intended missions. Both Voyagers have ventured into the mysterious region of interstellar space, becoming the first human-made objects to do so. However, after 45 years of service, these technological pioneers are now sending warning signals back to Earth, a clear indication that time and the harsh conditions of space are taking their toll. The news of Voyager's distress signals has garnered widespread attention from scientists, space enthusiasts, and the general public alike. What do these warning signals mean? Are the Voyagers nearing the end of their journey? And what does this signify for the future of interstellar exploration? This article delves deep into the significance of these warning signals, examining the incredible journey of the Voyager spacecraft and exploring their role in pushing the boundaries of human knowledge. The launch of the Voyager missions, a journey begins. The Voyager missions were born during an exciting era of space exploration. In the 1960s and early 1970s, space agencies, particularly NASA, were focused on exploring the Moon, but there was also a growing interest in studying the outer planets. The gas giants, Jupiter, Saturn, Uranus, and Neptune, held many secrets that could provide insight into the formation of our solar system. One of the main reasons for launching the Voyager missions when they did was a rare planetary alignment that only occurs every 176 years. This alignment allowed the spacecraft to utilize gravitational assists, using the gravity of the planets to slingshot themselves toward the next target. This remarkable alignment enabled the Voyager spacecraft to visit multiple planets with minimal fuel usage, making it possible to explore the outer planets without requiring excessive resources. Voyager 2 was launched first, on August 20, 1977, followed by Voyager 1 on September 5, 1977. Despite the sequence of their launches, Voyager 1 followed a faster trajectory and overtook its twin sibling, eventually becoming the first of the two to leave the solar system. Both spacecraft were outfitted with a suite of scientific instruments designed to study planetary atmospheres, magnetic fields, and moons, and they were equipped with cameras to capture images that would forever change our understanding of the outer solar system. The Grand Tour, discoveries that redefined our understanding of the solar system. The primary mission of the Voyager spacecraft was to perform flybys of the gas giants and transmit back data about these enigmatic planets. Voyager 1's first target was Jupiter, and it provided stunning close-up images of the planet's turbulent atmosphere and its iconic Great Red Spot. The spacecraft also made groundbreaking discoveries about Jupiter's moons, particularly Io, which was found to be the most volcanically active body in the solar system. Voyager 2 followed a similar path, flying past Jupiter before moving on to Saturn. The mission was extended, allowing Voyager 2 to visit Uranus and Neptune, making it the only spacecraft in history to have visited all 4 outer planets. These flybys revealed numerous surprises, such as the complex and intricate ring systems of Saturn, the tilted magnetic field of Uranus, and the supersonic winds of Neptune. The Voyager spacecraft not only sent back stunning images, but also provided invaluable scientific data that challenged previous assumptions about the solar system. The moons of the gas giants were found to be more geologically active than anyone had imagined, and the intricate details of the planet's magnetic fields and atmospheres continue to fuel research to this day. A new frontier, the journey beyond the solar system. By the late 1980s, Voyager 1 and Voyager 2 had completed their primary mission. They had captured the first close-up images of the outer planets and sent back data that reshaped our understanding of these distant worlds. However, their journey was far from over. Both spacecraft were still operational, and NASA decided to send them on an even more ambitious mission to explore the boundary of our solar system and beyond. In the 1990s, the Voyager interstellar mission, VIM, was initiated, with the goal of studying the outermost regions of the solar system, known as the heliosphere. This bubble of charged particles, generated by the sun's solar wind, marks the outer boundary of the sun's influence. Beyond this lies interstellar space, the region of space between the stars, filled with plasma, cosmic rays, and dust. In 2012, Voyager 1 achieved a historic milestone when it crossed the heliopause, the boundary where the solar wind gives way to the interstellar medium, becoming the first human-made object to enter interstellar space. Voyager 2 followed suit in 2018. These achievements marked the beginning of a new chapter in space exploration, as the Voyagers began sending back the first direct measurements of the environment beyond the influence of the sun. Warning signals from the Voyagers. What's going wrong? After decades of traveling through space, the Voyager spacecraft are still communicating with Earth, but the warning signals they are now sending suggest that their journey may be nearing its end. These distress signals are not entirely unexpected. After all, the spacecraft were originally designed to last only 5 years, and they have been operating for more than 45 years. But what exactly are these signals telling us? In May 2022, NASA engineers noticed that Voyager 1's Attitude Articulation and Control System, ACS, which controls the orientation of the spacecraft, was sending back confusing data. The ACS is responsible for keeping Voyager 1's antenna pointed toward Earth, ensuring that it can maintain communication. However, the system began reporting erroneous information about the spacecraft's orientation, even though the antenna remained correctly aligned. This anomaly suggests that the ACS may be malfunctioning, potentially due to degradation of components after decades of exposure to the harsh conditions of space. Similar issues have been reported with Voyager 2, which also showed signs of aging as it continues its journey into interstellar space. While both spacecraft are still operational and capable of sending data back to Earth, these warning signals indicate that their systems are under increasing strain. The challenges of operating in interstellar space. Interstellar space is an environment unlike anything the Voyager spacecraft encountered during their exploration of the outer planets. The region beyond the heliosphere is filled with high-energy cosmic rays, low-density plasma, and extremely cold temperatures. The spacecraft are now operating in an environment that was not accounted for in their original design, and the wear and tear of 45 years of continuous operation are becoming evident. One of the biggest challenges the Voyager spacecraft face is the gradual loss of power. Both Voyager 1 and Voyager 2 are powered by radioisotope thermoelectric generators, RTGs, which convert the heat from the decay of plutonium-238 into electricity. However, the power output of these generators decreases over time, and after more than 4 decades, the spacecraft are operating on less than half of the power they had at launch. NASA has been gradually turning off non-essential systems to conserve power, and in the coming years, more instruments will need to be powered down as the available energy continues to decline. Eventually, there will not be enough power to operate the remaining instruments, and the spacecraft will fall silent. Another challenge is the weakening of the spacecraft's communication systems. As Voyager 1 and Voyager 2 move farther from Earth, the signals they send become weaker. At their current distance, over 14 billion miles from Earth, it takes more than 20 hours for a signal to travel from the spacecraft to NASA's Deep Space Network, DSN. The DSN must carefully amplify the faint signals from the Voyagers, and even small misalignments of the spacecraft's antenna could disrupt communication. The cold temperatures of interstellar space are also a concern. Although the spacecraft are designed to withstand the extreme cold of space, the frigid temperatures of the interstellar medium are putting additional strain on their aging systems. The spacecraft's instruments, which were not designed for this environment, may become less reliable as they continue to operate in these conditions. The significance of the warning signals. The warning signals from Voyager 1 and Voyager 2 are a stark reminder that these spacecraft are nearing the end of their operational lives. However, this does not diminish the significance of their achievements. The Voyagers have already exceeded all expectations, providing invaluable data about the outer planets and the boundary of the solar system, and becoming the first spacecraft to enter interstellar space. The data they are sending back from this unexplored region of space is of immense scientific value. For the first time, humanity is receiving direct measurements of the environment beyond the heliosphere, including data on cosmic rays, plasma, and the structure of the interstellar medium. These measurements are helping scientists to better understand the nature of interstellar space and the processes that govern the boundary between our solar system and the rest of the galaxy. While the warning signals indicate that the spacecraft are struggling to maintain their systems, they are still providing valuable data. NASA engineers are working diligently to troubleshoot the issues and keep the spacecraft operational for as long as possible. However, there is a growing sense that the end of the Voyager mission may be approaching. A legacy of exploration. The Voyager mission is one of the most successful and enduring space exploration missions in history. What began as a mission to explore the outer planets has turned into humanity's first journey into interstellar space. The discoveries made by the Voyager spacecraft have revolutionized our understanding of the solar system and opened up new frontiers of exploration. One of the most iconic aspects of the Voyager mission is the Golden Record, a time capsule that was included on both spacecraft. The record contains sounds and images from Earth, including greetings in 55 languages, music from various cultures, and natural sounds such as birdsong and the sound of ocean waves. The Golden Record is intended as a message to any extraterrestrial civilizations that may encounter the spacecraft millions of years from now. The legacy of the Voyager mission extends far beyond the scientific data it has provided. It represents humanity's insatiable curiosity and our desire to explore the unknown. The mission has inspired generations of scientists, engineers, and space enthusiasts, and its impact on the field of space exploration will be felt for decades to come. The future of interstellar exploration. As the Voyager spacecraft continue their journey into interstellar space, their mission is serving as a stepping stone for future exploration. The data they have provided is informing the design of new missions that will build on their legacy and push the boundaries of human knowledge even further. One such mission is the Interstellar Probe, a concept being studied by NASA. The Interstellar Probe would be designed to travel much faster than the Voyager spacecraft and reach interstellar space in a fraction of the time. Advances in propulsion technology, such as solar sails and nuclear propulsion, could one day enable spacecraft to travel to nearby star systems, opening up new possibilities for exploration. While the Voyager spacecraft are nearing the end of their journey, the lessons learned from their mission will continue to shape the future of space exploration. The warning signals they are sending back to Earth are a reminder that space exploration is a challenging and unpredictable endeavor, but they also serve as a testament to the resilience of these pioneering spacecraft. Conclusion. After 45 years in space, Voyager 1 and Voyager 2 are sending warning signals back to Earth, indicating that their systems are struggling to cope with the harsh conditions of interstellar space. These spacecraft, which were originally designed for a 5-year mission to explore the outer planets, have far exceeded expectations, traveling beyond the solar system and becoming the first human-made objects to enter interstellar space. The warning signals mark the beginning of the end for the Voyager mission, but they do not diminish the incredible achievements of these spacecraft. The data they have provided has transformed our understanding of the solar system and opened up new frontiers of exploration. Their journey into interstellar space is a testament to the ingenuity of human engineering and our desire to explore the unknown. As we reflect on the legacy of the Voyager mission, we are reminded that space exploration is a journey of discovery, one that requires perseverance, creativity, and a willingness to push the boundaries of what is possible. The Voyagers may be sending distress signals, but their legacy will endure, inspiring future generations of explorers to continue reaching for the stars.